Good morning, John Gilkison here for the Aero Stealth channel. I've been wanting to shoot this video for quite a while. I've been working on it the last few weeks. There's been a controversy come up over the last several months about whether electric vehicles can tow, and the take on it is, of course, not that they can't physically tow trailers, but it really reduces their range a great deal. And while all this is true, it begs quite a few questions. And we felt it really needed to be addressed because we don't have an electric vehicle towing problem. We have a trailer aerodynamics problem. And electric vehicles tend to be made very aerodynamic in order to make the most out of their power supply because their batteries aren't as energy dense as gasoline. And here you take an aerodynamic vehicle and hook it up to a trailer which is really dirty aerodynamically, and yes, you have a serious problem. So we want to outline that, and I'm probably only going to make it halfway through this PowerPoint presentation, so we're going to do this in two parts. So here we go. And this is our first slide, and it's titled Stealth Trailer Towing, parentheses, for EVs. And what it shows here is a Cybertruck towing a trailer that actually reduces the drag coefficient of the combination. So the air comes off the truck and lands on the gap filler here and goes off the trailer, and the wake area is reduced behind the trailer over what it would be from just the truck alone. So let's say this truck had 500 miles of range, or 600, or whatever. It might have 50 more miles of range or more. Towing a trailer like this with extra weight. A lot of people think mass is a problem when towing, and they're concerned about weight, but it's not actually, and there are reasons for that. Here's a good example of it. I own a fifth wheel trailer that's 32 feet long and weighs 9,000 pounds and has 100 square feet of frontal area, and yet I get 9.5 miles per gallon. And Phil Knox, who did all these drawings for me, has a friend, a neighbor of his in Texas, that owns a trailer that's only about 24 feet long, weighs less than my fifth wheel, but it's a tongue hitch trailer, and he only gets like 8.5 miles per gallon. So this tells a tale. What we have here is a gap closure because the front of the trailer is so much closer to the rear of the cab, and we have a sloping roof line that goes downhill, and the underbelly of the trailer is paneled in. We also have a gap closure here, and this trailer my trailer would really benefit from a boat tail that was foldable like you see on semi trucks. I could get about 10.5 miles per gallon if I had such a thing. Trailer towing 101, and this is important. When you're towing a trailer, you no longer have the vehicle you're driving. You have a different vehicle. So here's a sedan separately with a drag coefficient of 0.53. Here's a trailer separately with a drag coefficient of 0.62. And as you can see, the CDAs are radically different, coefficient of drag area, because the trailer is larger than the sedan. But when you hook them up together, you get a new animal entirely. And it's the drag coefficient now of the combination is 0.726, and the CDA has went up to 39.35. So, however, paradoxically, the sedan's coefficient of drag drops 43%. But this is relative to the combination, obviously. and the trailer CD drops 4.8%, but the CDAs for the tow vehicle and the trailer are added, and typically the CD for the rig is based on the frontal area of the trailer. So in the example shown here, the coefficient of drag equivalent as far as the motor of the tow vehicle is concerned is 1.6. So you can see towing a trailer can really exacerbate the amount of power necessary and reduce your range, obviously, because the engine has to provide a lot more power. But this gap closure thing is very important. This is a series of panels here that shows from the closest gap to the widest gap on a trailer. And you start out with a very close gap, and its drag coefficient is 0.53. But when you widen the gap up to a normal gap that you use for towing trailers, it's 0.65. So you've lost a full point. It would be really nice, and I think this would be a great invention, to have an electric motor device and a cogwheel or something that would, once you got up to 45 miles per hour, where the aerodynamic forces become important and you're not making any tight turns or anything, to go ahead and draw the trailer in and close the gap like this. And as soon as your speed got down to below 45 miles an hour, it could be let back out automatically. And this would improve the range and reduce the amount of fuel you needed to tow. Just this simple device. Here's kind of an explanation for some of this. This is a wing section, which basically that's what all vehicles are. There's wings going down the road. Very poorly designed wings, but you see, if you have a gap in a wing and the gap's very far forward, the coefficient of drag is higher than when the gap is further back. In these next, as you see in these next two panels. Of course, having two gaps is even worse. So let's say you're towing with a pickup truck and the gap is here, or even here, let's say, and you end up, you switch and you take a trailer and you tow with a Tesla Model X. Well, the gap ends up being here because the Tesla Model X is a shorter vehicle than the pickup truck. There's other things going on, but every towing scenario is different from every other one when you use different vehicles or different trailers. Here's a British invention, which they used an inflatable unit to attach to the front of the trailer, and it's kept inflated by a little 12-volt pump, and it fills this gap up. And this offers a 56% reduction in drag and a 26% increase in fuel economy. All for, a few watts of a pump, just to keep it inflated. And of course, if you went to make a tight turn or something, and the vehicle actually ran into the edge of this thing, there'd be no harm. So this is a great idea. I wish we had such a thing here. You'd have to fabricate one of your own to make it happen, as I understand it. Bed covers and camper shells. So here's a truck, naked, and then this is a truck with a bed cover. And we've reduced the coefficient of drag of this truck. So this would be helpful if you were towing a small trailer and driving the truck in everyday use. But if you had a taller trailer that was the height of the truck, then a cab high camper shell would be the way to go, because then the trailer could hide in the wake area of the truck, and the air would be a lot cleaner. And if you had an even taller trailer, a camper shell that was taller than your truck would be the thing to do. However, when you weren't towing the trailer, you should take the camper shell off your truck in this last instance, because it would decrease your fuel mileage. So it would increase it when you were towing the trailer. It would decrease it when you weren't. So um, this, the trucking industry has known about all this stuff for 40 years. NASA did studies in the late 70s and early 80s about this, and this is why you've seen all these developments on trucks over the last 40 years. This cab fairing here blends the air in over the trailer. It's concave in the back so they can make turns. And you have a boat tail on the back here, which is foldable. So it'll fold in so you can open the back doors. And then you have an aerodynamic fence down here to keep air from out from underneath the trailer. Now there's more that can be done, but this is a local trucking company out of Las Cruces here. It's called Mesilla Valley Transit. So I like to brag on them. Semi-trucks can travel over 100,000 miles a year, and as you can imagine, this is several % reduction in the amount of diesel they need to buy. That can really add up. So it's worth doing for them. That's their bottom line. Here's 3 tow vehicles towing a box trailer. This is a pickup truck. This is a Tesla Model X, and this is a Tesla Cybertruck. Of the 3 vehicles, the amount of energy these combinations require to go down the road, this pickup truck up at the top is the lowest, believe it or not. Now that said, the input energy for the truck is a lot higher because the truck's probably only 20% thermally efficient in using the energy in that gasoline, whereas the electric vehicles are 90% efficient. However, the actual amount of energy needed to do the work is more in these 2 instances. So all this is counterintuitive to a great deal of people, but it needs to be stated that everything ain't as it seems or looks. Now, if you took a Tesla Cybertruck, in this example here, and you put a cab-high camper shell on it, it would be even better. And then if you had a raised camper shell like this would be the lowest energy you would need to tow in the example of the previous slides, right there, by far. And even a gas truck set up to do this same towing with the same thing, if it had this cab-high camper shell that shot up, angled up a bit, it still would take more energy because of the radiator air inlet. So here we are. I'm just doing this internal combustion engine versus electric vehicle towing input energy math to explain all this, and then we're going to stop the video. So let's say it takes 850 watt hours per mile to tow a trailer. And it doesn't matter, either class of vehicle. That's what it takes. And it doesn't matter what it's powered by, whether it's electricity or hamsters. So the internal combustion engine is only 25% thermally efficient, and that's being generous. Would need 850 watt hours divided by 0.25. You take 3,400 watt hours per mile of input energy, or 9.6 miles per gallon net fuel consumption. If the truck had a 26-gallon gas tank, it would still have a 249 miles of range. If this truck had only a 3-gallon gas tank like a Tesla Model X has, it would have less than 29 miles of range. An EV at 90% efficiency would only require 944 watt hours per mile of input energy, not including charging losses, to tow the same trailer, and it would net 34.7 miles per gallon equivalent. Now let's compare these. 9.6 miles per gallon net fuel consumption, 34.7 miles per gallon equivalent for the electric vehicle. It's 3.6 times better. Because the Model X only has a 3-gallon gas tank, its equivalent range would be reduced to 104 miles. This is the apparent EV towing problem. In a nutshell, this is why applied aerodynamics is so important for the future of electric vehicle towing. This will be true of the Tesla Cybertruck, even with the 200 kilowatt hour battery pack. Any aerodynamics that increases range even by 20 or 30% will be of critical importance. I'm going to let you go for here, and we're going to resume this with part 2 and finish the PowerPoint presentation. We'll see you on down the road, everybody. Bye-bye.